Okay, are we live? Yes. Hello, hello. And did I change the audio? Yes, because last time I streamed, the audio was super, super faint. And then I had to crank it up during the record. It was kind of not good. And so what do I have in here? This is not. Okay, I'm just gonna get rid of this. Uh, and okay, I think. Are we ready? What do we need? What do we need? What do we need? What do we need? Are we ready for this? I get. Oh, and we are ready. And do I have my coffee? Yes. I should have brought my parametric cam cup this time. Okay. All right, beautiful. Are we ready for this? Three, two, one. Hello! How's everyone doing? Good morning, good afternoon, good evening, good midnight. Well, I don't know where you're hearing this from. Good early morning for those folks in the West Coast who wake up at 6 a.m. to watch this. I know there's some of you. Good morning, good morning. Drilon, hello, how you doing? Victor, is the volume a little low? Are you sure? Can you please confirm? Because I see it pretty high on my end. Hello, hello. Yes. Like I see it pretty good on my end. I don't know. Abar, hello. How are you doing, sir? Edgar, yes. I think the volume is actually where it should have been in the past. It was not working at the beginning because I hadn't connected my microphone, basically. Yes. Hey, Albert. Albert, what is your face? Like it's not there anymore? Gintars, hi, how you doing? Have we met before? Welcome to the channel if we haven't. All right. So what do we got going on for? Okay, well, sorry, the boilerplate. Hi, if you're new to this channel, my name is Jose Luis. I run this thing called Parametric Cam. We do computational design live streams. We just gather here, we do tutorials, then we edit them and we post them online. We make playlists, we help people learn computational design techniques. We hang out, we discuss things. It's great. I have a lot of fun. I love doing this. As you may know, I have not been great at doing this last year. I was catching up with life. Life's gotten complicated this recently, but hopefully I am getting back on track at doing this again this year. Mm, well, that's great, Gintars. So welcome to the chat and welcome to the channel. As you will see watching the videos here, as I record them, it's arguably more painful because I go back and forth a lot, but it's also much more interactive. I have the opportunity to chat with you, and I have the opportunity to get input from you folks as I am recording, and sometimes actually your questions inform the video that I'm recording live, you know? So it's very interesting. Anyway, so if you want to know more about us, we should get a Discord icon over there, right? We should probably get a Discord icon at there. Yes, we're gonna have to do that. I'm gonna write it down. I'm gonna get myself a note. Where do I have? All right. Discord icon. See? Got it. Beautiful. So it's happening now. It's gonna be here right next to my remember to record the introduction note. Can someone just make like a nice thing on Illustrator or Photoshop with the parametric cam logo or something, and then just like share it on Discord so that I can have nice things, you know? We like nice things. Anyway, okay, so yes, so if you want to know more about what we do, just follow us on social media. We're particularly active on Instagram, for example, and we do have a Discord server that we use to have conversations offline throughout the week. The name of the server is Parametric Camp, but if you want to join, there is a link on the description of this video that you can use to join us. Just join the server, go to the introduction channel, say hi, who you are, and then we make announcements every time we go live on Discord. So yeah, and that's where I actually get to meet most of the people and hang out and understand what's going on in the world. Okay, so what are we doing today? Well, first of all, we had a poll going on. This is very important. Where are we? Oh, yes, sorry, here. So we had a poll going on topic suggestions. Last week, I asked members of the community to vote for which topics you would like to see turned into tutorials or turned into maybe full-fledged playlists. And Arasto, who's like one of the coaches in the camp, was kind enough to put together this poll. Wow, I have not had enough coffee this morning. To put together this poll that you can see here. And basically the way to vote is just to look at what topics are you interested in and then just punch the button to get a vote in. And I mean, it's not that I'm going to close the poll or anything. This is just going to stay there. But if we look at the results right now, we can see that, oh, sorry, I actually unvoted this. You can see that the results are that most people want, what was this? Rhino Insight, then algorithmic modeling challenges, then OpenAI in Grasshopper, and then online repositories and Git. And then, what was this? Parallel computing. And then, other, let's call it these other programming languages. So I actually think all of these are super legit topics and I would love to cover them. At least the first four. I don't know about parallel computing and definitely I don't know about this one. But Rhino Insight, I'm going to disclose this fully. I'm not a great Rhino Insight person. I've been using it very little. So did someone just vote? So everyone, if you're listening to this right now, you're welcome to join Discord, go to topic suggestions and vote right now. It's absolutely fine. Then we have algorithmic challenges. I was actually quite surprised about this one because I didn't know algorithmic challenges were that popular, but it's great. And I'm very much in support of, yeah, I don't know why I unvoted this. I'm very much in support of, doing more of this because they're actually quite fun. They're easy to record. It's nice to do them every once in a while because like sometimes we're just making like a long playlist and the thing gets a little boring. So, and then this one, the brain, OpenAI and Grasshopper. So that's going to be interesting because I feel like we've kind of done some work there in the playlist that we have. What is the playlist? So that would be, what is it? Where are we? So that would be here. That would be in playlist. We have a playlist called Fun with DALL-E. And in this playlist, we've already done how to use the DALL-E API in Grasshopper. So I guess something I want to do definitely is that I want to, this would be amazing. We're so gonna do this. We're gonna make a community plugin for Grasshopper. And that's gonna be a plugin that we're gonna start in this channel, but all of us from the community are going to contribute and it's going to be an AI it's going to be an AI plugin. And we're gonna make components to ping all possible AI-powered services that are out there. For example, OpenAI is probably the most popular one these days. But we could also probably ping IBM Watson. We could also probably ping some Hugging Face. We could probably ping Hugging Face. We could make something really interesting. Hey, Andres. Hola, how are you doing? I'm going to do something, Andres. Yep. All right. There you go. And so I want to make this plugin, all of us, I want to start it here in the channel, but I want all of us to contribute and to build on top of it. That would be super, super fun. And I also want to do that because I don't know if I've told you already, but the folks from Rhino, from sorry, the folks from McNeil Barcelona reached out and to invite me to give a talk in their webinar series. So I'm going to be giving a talk on AI and Rhino and Grasshopper, etc. At some point, I think it's going to be in May. And I would like to show that plugin in that talk and talk about things that you can do and build examples, etc. So I think we could use some time in the channel to build up those tools and then throw them out there in the wild for people to use them. So we're definitely going to do that, and that's going to cover perhaps OpenAI in Grasshopper, and then Git. So this is online repositories, Git, GitHub, etc., which I've been meaning to do for a long time because it's a very useful thing that I never have the time to teach in my courses. Hey, Chandra, how are you doing? It's something that I've never had the chance to teach in my classes, and it's also way too technical. I'm not interested. It's a little too technical for example, for my courses at the university, but it's very useful to have so I really want to do this. So if we manage to do, to finish the playlist, the advanced development, and if we manage to do some Rhino Insight, more algorithmic challenges, more OpenAI, and more Git, this would be a fantastic 2023, I want to say. So can we make a public commitment to a New Year resolution in February? Can we make a commitment to finish advanced development in Grasshopper? That's going to be, I'm going to formally, all right, because yes, so we're going to do, what are we going to call this? Parametric Camp New Year resolutions. And I'm going to make markdown here so that it looks better. So that's going to be finished the advanced development in Grasshopper course. We're going to finish that one. Development in Grasshopper course. That's going to be one of them. The next one is going to be, what is it going to be? It's going to be kickstart the, what are we going to call this? Brain plugin in Grasshopper. I don't know. Some OpenAI and other online ML tools. Okay, so for example, we're going to start that, and then we're going to do a full Git playlist. I don't like to call them playlists. I kind of like to call them like courses, if you will. Okay, and then record at least 5, because when we make commitments, like having some kind of measure, record at least 5 algorithmic modeling challenges. Okay, and then algorithmic modeling challenges, and then what else? Oh, Rhino Insight, which is actually what are we going to do about Rhino Insight? Is it going to be a playlist? Is it going to be a few examples? How is that going to work? Okay, so this one, I need to think about it. Do something with Rhino Insight. I'm not sure what this is going to be, but we may think about it. Okay. Okay, so and I think they're gonna go about in this order. So we're gonna finish the advanced development. We're going to do the algorithmic challenges here and there. We're gonna do the brain plugin as soon as possible. Then we're gonna do the kit, and then we will wrap up by doing some Rhino Insight. Does Puppeteer Playwright violate OpenAI terms of what? What is Puppeteer Playwright, Victor? I don't know what you're talking about. Can you share links to Puppeteer, Playwright, whatever that is here in the live server? Would you mind doing that? Okay. And I actually do have a, what is it called? I actually have a, like this place where I record everything that I want to do. I guess, well, I have a lot of stuff here. Well, I'm gonna copy this to my main live stream ideas for 2023. Playwright, Puppeteer and Playwright. Okay, interesting. What is this? Puppeteer. Puppeteer is a Node.js library, provides a API to control Chromium over the dev. Puppeteer runs. Ah, so Puppeteer is basically controlling a Chromium so that you can impersonate. So you can make it basically make bots with a browser. Correct? Is that what you're saying? Information, testing, okay. And then Playwright. What is Playwright? I guess it's probably something similar. Is that? And it was reliable end-to-end testing for modern web apps. Any browser, one API, cross-browser, Playwright support, full isolation. Ah, so you're saying it's a way to use OpenAI without using the API in code. And I guess the advantage of doing that, what would be the advantage of doing that, Victor? Because at the end of the day, when you use OpenAI, I mean, if you use DALI, if you use their DALI app, if you use, where am I? If you use their DALI app, you still go through the credit system. You still have credits. So it's not that you can bypass the credit system. And if you use ChatGPT, I mean, it would take forever. It's just not very. Why do you think, Victor, you would want to use Puppeteer or Playwright with for OpenAI? So that's one thing. The other thing, which is quite interesting that you bring it up, is the fact that, yeah, you're using a robot to talk to another robot. It's like, oh, excuse me. It's like, push, right? Oh boy. Okay. We're getting super meta here. Okay. So now, for the algorithmic JS content, just thought it'd be interesting to cover. Ah, JS content. I mean, it could be interesting, but it's a little, I find it a little niche as a use. It's basically, I mean, it's the topic, it's the kind of thing that you would write if you want to have a bot to buy graphics cards or something like that. I don't know. Well, anyway, for the algorithmic modeling challenges, maybe we could start a poll for this one and gather recommendations about things that we could model algorithmically. So I'm actually going to start that right now. Hello, everyone. Looks like we are going to record a few algorithmic challenges this year as per popular request. I want to, and then this. Can you suggest some topics of things we could model, things or buildings? Because at the end of the day, I'm still kind of an architect. With this, we could model algorithmic, algorithmically. Is that how you spell that? There you go. There you go. Beautiful. Beautiful. Okay. All right. And it's already half an hour. Okay. So, and there's no way to use OpenAI inside Grasshopper without registering monthly and get the API code. Yeah, there's no way. You have to pay some money to use. You have to pay some money to use. OpenAI. It's their business model. Okay. So, who is this? Shuruk. Body face. Yes. Okay. So, all right. So where were we? Okay. So we're gonna close this up, and I need to catch up. Where were we in parametric camp? So, your channel, playlists, advanced development in Grasshopper. We finished how to properly update and deprecate your code. What that means is that the next thing that I have on my list is importing and using libraries in your plugin. And then discussing the distribution and the bundling of the DLL and licensing issues and examples from the plugin. Okay, so we can do that. We can do that. So how can we do that? So where have we done external libraries here before? How to load external libraries. We did that for mesh components. Hi, this is Jose Luis here at Parametric Camp, and welcome to another video in. Okay, this is actually quite loud, correct? In our series, Advanced Development. It is quite loud. It is quite loud. Maybe I should change the settings. Desktop audio, -10, and now in Grasshopper. You may see that might be still quite loud, but anyway. Yeah, so what I did here was I made a tiny library. Yes, I made a DLL. I made a DLL, person class, learning external assemblies. And then we also did, yes, we also did, so that was one. And then the example was in mesh components. Then we did, with the mesh components, we did. There is something about the structure of the vertices in the faces mesh that to mesh is the in itself to accept some target. Okay. So I guess what I need to do in this example, sorry, it's the last time I recorded a video for this place, it was 8 months ago, which is shameful, but I need to get back in the mind of like, how were we doing this and what was the rationale. I really want to finish this playlist. Folks, we really need to make this happen. So I guess I had a project somewhere, right? Let's start with the basics. Pavilions. Okay. Wasif, are you, because you are, concrete GB parametric was if any good example of a pavilion. All right. And I'm going to put that aside because if I start chatting during the live stream, this is never going to end. Okay, so I guess I had a... Yes, we had the Grasshopper plugin project here. We had the solution. Yes, we had this here. And then we had deprecation. And in deprecation, update them. Hello, this is Jose Luis. Okay. That I typically use is that still works because I haven't changed, right? Well, look at my hair. What happened with my hair in this live stream? So, wow, but what was going on there? I have two problems here. First, well, so then I guess if the next video is going to be me with all this long hair, there's going to be quite some contrast, huh? Okay. Okay, so we were deprecating plugin version obsolete. Okay. And we did have So I guess the good thing to do here would be to replicate some of the stuff we did here in the plugin using the D3, the I forget what it was called, the mesh library. Do it here and replicate it, just to show how that works. Because I think the class, I don't know that it's interesting to do like the person class. This is kind of little lame at this point. We can probably just not do it. Yes, so let's go then to the parametric cam plugin, which, by the way, it's not versioned. It's not on Git. That's kind of strange. So yeah, so whatever. I guess components. Then we do have some. I do have a Rhino. Sorry, folks. It's just I haven't done this. I have totally forgotten how we were working with this playlist here. Is my audio still good? How are we doing battery-wise? I think the battery looks good. So I think we had this. Is that correct? And then we had this. Yes, very good. And we had that one, and we had the vector preview. Yeah, so this was the sample file that we were using to test the components. Thank you, Abar. I actually appreciate that. Okay, so this is deprecation. So then, but this is not the same as the file that we were using here. So for mesh components, where do I have that? That's a very good question. Do we have that on the GitHub? Advanced development in Grasshopper, mesh component. Oh, we do have it here. And we have the person class, we just don't have the project that we were building. So let me open another Rhino here. Let me open another, so that's going to be mesh components here. And then this is going to be mesh components. And this is not available, geometry 3. because I moved things around. Oh boy, where did I put this? That's a very good point. That is not there anymore. I guess it's not. Oh, I know what it is. Which probably shouldn't be there. Wait, where is that? Actually, wait, I've lost track. Oof, folks. Geometry 3. Okay, so I guess we're gonna move it to the repo. But before we do that, before we do that, can we check if we can distribute this? Oh boy. And my computer is, oh. Okay, I need to restart this. So can we geometry 3 C# library? Can we check the license and see if we can distribute this? The license. Boost software permission is here to future to use, reproduce, display, distribute, execute, and transmit the software, and to prepare derivative work of software. Copyright notice in the software, including the above license grant this restriction to the following disclaimer. Unless such copyright, but a source language processor. The software is provided as is. Okay. So it does have a boost license. We can distribute conditions. We need to attach the copyright. So basically what I've done is I have added here, we're going to talk about this in the video actually, where I have attached the library here. We're going to distribute the library in our repo. But I just want to make sure that I comply with the license, which means that because we can distribute the file, so that's great. And then the only thing that we have to do is we have to make sure that this license is attached. So I'm going to download this license here, and then I'm going to put it in the GitHub repo, advanced development, and then what is it going to be? It's going to be called geometry 3 underscore license. And then you can see that, and should be a text file. Okay, so now we have geometry 3, we have the license, and I think this should be enough, legally speaking, to comply with the requirements of the license. Okay. New wheel tech, and this is like a more modern. Okay. So I think we should be good. And then if I open this again now, Sandy, how are you doing? Hey, good to see you. Okay, we're gonna open this, and then now we should have this should work, hopefully. Yes, because the library is basically attached in the same folder as these guys. And then here we have mesh to 3D mesh. We basically convert this thing, we output a 3D mesh, and then probably we want to just take one of these simpler ones and port it. Reduce triangles. reduce triangles, reduce edges, remesh, remesh and analysis. We can probably do remesh, which is kind of fun. And we don't have that in native, in vanilla Grasshopper, I believe. Correct, folks? At any rate, we will eventually, and then unmesh again. We can build these three components so that we can take a grasshopper mesh, we turn it into a demesh, we remesh it, and then we unmesh it again. Well, because I don't think we can do that in. Can we remesh here? No, if we can. Anyway, I don't know. So, and that could be fun, actually. And so we're gonna do that. And then I see, wow, I see a lot of stuff here. Whoa! Can we optimize panels for this? Whoa, right. Pathfinder, get panels almost in the similar dimension, but just, I think you can do similar things without using AI. Whoa, 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 okay. Voronoi sweepline algorithm might be a good idea. I actually want to do that a lot. Hey, no, how are you doing, sir? Straight skeleton algorithm. I like this a lot. GB parametric. I actually like this a lot. Nice. Okay. All very good ideas. Thank you. Okay. So I guess the way we're going to do that is mesh to demesh 3. And then we're going to do demesh remesh. So these should be actually demesh 3 remesh probably. And this should be demesh 3 reduce edges. And this should be demesh 3 reduce triangles. Demesh 3 reduce vertices, analysis, and we can probably demesh to demesh, demesh to mesh, and this one demesh 3 to mesh as well. Sorry, I got a little bit of OCD going on here. Well, so I think we can then, and then we can just implement those here. And in the plugin, we are going to create, what are we going to create? We have mesh components, simulation, and in the plugin, we're going to create, I guess, mesh components. I'm going to make this a little bigger so that we can record it properly. And I guess I'm going to make a folder here called mesh components. And we're going to make our components right there. And what I do want to explain is the idea of importing a library, right? How to import the library, then we're going to build the components, and then we're going to build the components, we're going to show how they work. We're going to show how they work. Did I have some kind of thing where I was launching? Yes, I was launching a... Huh, nice. I was launching components here, and I was launching, I was opening here components as well. Ugh, boom. What happened here? Yes, I was getting some okay, and then this was in debug mode. Okay. Okay, so here, And then this is the previous thing, and we don't want, I already copied this somewhere else, so we're gonna close this. Do I have it copied somewhere else? Oh wait, I actually didn't. Oof, oof, good thing I didn't. There you go. Okay, so we're gonna get rid of this, and we are going to now geometry 3 sharp. So where did I get a distribution file from? From NuGet. Oh boy. So what did I do in the video? In the video, how did I actually download mesh components? Actually very fond of this library called Geometry 3 Sharp, created by Gradient Space, which I believe is kind of a brand name that the author, Ryan Smith, has been working on for. So, all right. So I need to figure out where did I get the DLL from so that I'm consistent with my previous video. Okay. So, okay. So, also I built it. So I did build the DLL from the project. Yep, I did build it, yes. From mesh components. Okay. Well, that's a long question. Maybe I will address that a bar once we finish recording, okay? Remek, thank you. Sandy, I'm good. Good to see you. Sorry, I'm still all over the place. I need to reconnect with this playlist. So the way... Okay, so I did build that file manually instead of using the NuGet manager, which means that here I probably want to... What do I want to do? What do I want to do? So, and then if I make changes here, actually, I could have used the live reload version in the new Visual Studio. Wow, that would be cool. Huh. Anyway, the hot update, I think it's called. Okay, so all right, so we're gonna record the introduction later. I'm gonna get myself a note here, just to not forget. And then this video, we're going to start by saying, well, what we're going to do is we're going to follow the similar logic as the one that we did for this video, where in C Sharp, we did build these components that loaded the libraries, and then we're able to perform manipulations. Yes, exactly. We're able to perform manipulations here, and then I'm going to point you a link so that people can watch this video. And then after I do that, the first thing that I would like to discuss is, well, the first thing that we need to do is I'm going to create a mesh, and I'm going to go here and take a look at, we're going to replicate mesh to 3D mesh. So we're going to bring this function here. We're going to create a component that is going to be mesh to D mesh 3. And it's going to take a mesh and it's going to output a D mesh 3. And probably I want to have that done here. So I'm going to do that right now here. Am I going to do that? Uh, I'll do it. I guess I'll do it as we go. And then, so I create the component, and then I want to build the component. I will want to create the mesh, but then for the mesh, I will need to basically make this, but then I won't have access to a dmesh3 object, which I will need to upload. I will need to load by loading the library. And then I will show how to bring the library into the project, bring the library into the project, and bring the library into the project. What are we going to do? Bring the library into the project and then load the library. And then I will make the components. And then I will show how when you build the plugin, the library comes with the plugin or it doesn't. I actually am not sure. I will have to talk about that. And then after that, we will talk about licensing, okay? We will talk about licensing here. Okay, which is very important. We need to be cool, all right, folks? All right, great. Okay, so shall we get started? Okay, let's start recording after an hour of live stream. We can finally get started, but I apologize. It's just that I needed time to reconnect with this playlist and like get back into the rolling of where the files are, what were we building, etc., etc. But I think I'm good now, so we could probably get started. Okay, and the last sip. How's everyone doing there in the chat? All right, let's do this. Ooh. By the way, I don't know if you follow the news, but today in Boston we have the coldest day in decades. I think it's going to be minus 20 Celsius tonight or something like that. It looks really grim. Outside is very, very windy. It looks awful. So let's get done. Let's get going. And before we start, what I will probably say in the introduction is that I'm going to be doing components that do mesh manipulation, but they use an external library. So I want to show how that works. And I will show an example and then let's see how to build that. Okay. Fantastic. Let's get started. So how are we going to do this? Well, what I would like to do is I would like to follow a very similar process to the one that we followed in the mesh components video that we recorded a while ago. And if you don't remember it, there will be a card popping up somewhere in the corner all the way over there, or there will be a link in the description of this video. So what we did in this exercise was we used C# script components to create mesh manipulations, and I actually had the example somewhere here. We did C# script components where we did mesh manipulations, but in order to do these manipulations, we loaded an external library called geometry3. And what we did was we turned a standard grasshopper vanilla mesh, we turned it into a dmesh3, which is the type of class that represents meshes in this library that we're using. And then we use the library's functions to do analysis, reduce vertices, reduce triangles, etc. which are very interesting operations that we don't have in vanilla Grasshopper. So what I would like to do in this video is I would like to replicate the component here that we have, the remeshing, which is one of the ones that I find more interesting, right? Which is basically changing the topology of the mesh to target a new set of edge lengths, etc. But in order to do that, we will also need to replicate first the component that takes a standard Grasshopper mesh and turns it into a dmesh3 object. Then we will have to replicate the remeshing component, and then we will have to replicate the component that deserializes a dmesh3 components and turns it back into a mesh that Grasshopper can understand. So we're going to go and do the three components. If you remember in the previous video, we did this with C# scripting, and what we did was we managed the assemblies and we loaded the Geometry 3 library in this C# script component. We're going to do something very similar, but we're going to do it natively in our plugin. So let's get started. So the first thing that I'm going to do is I'm going to create here, and I don't know if you can see it, I'm going to create here, I'm going to add a new folder, and I'm going to call this meshes, I guess, or mesh components, for example. Mesh components to be consistent with the naming that we have used in the past. And then here, I'm going to add a new item, which is going to be of the type empty Grasshopper component, all right? Then I'm going to rename my component, and I'm going to call it, for example, what am I going to call it? I'm going to call it, we're going to do first the mesh to dmesh3. So we're going to convert, so that's going to be mesh to dmesh3 component. And that gets renamed here, it gets renamed here, and then I'm going to call this mesh to dmesh3, and the nickname is going to be mesh to dmesh3, for example. And then converts Grasshopper mesh to a G3 dmesh3. Okay, and in categories and subcategories, I forget what were we doing. So pcamp and nerve. So I guess this is going to be pcamp, which is the name of the library, and this is going to be meshes, for example. Right? Nerves, meshes, in vectors, we had vectors, so I guess it's going to be called mesh. All right? Beautiful. I'm very lazy when it comes to typing these things, so I'm just going to copy a lot here. So I'm going to say the input is going to be, it's actually not, I'm going to have to type it here. So the input is going to have to be a mesh parameter. So that's going to be something that takes a mesh as an input. The name is going to be, for example, mesh. The nickname is going to be M. And then the description is going to be Grasshopper mesh, for example. And then the access is going to be item, because for each mesh that we take in, we're going to turn it into one dmesh3 mesh. Okay, I'm going to make this a little bigger. And then here in pmanager, so I would like to add another parameter. This is going to be the output one. But for this one, what's interesting is that the output is going to be a type that does not exist in the Grasshopper or the Rhino API. What that means is that we cannot say here add parameter, add mesh3 parameters, because that does not exist. The way to handle this in the API is that to add a generic parameter or an object, there's no object, it's generic. Add a generic parameter. What that means is that it's going to output an object of any type, and we don't have to, we will deal with what that looks like after in the next, in the components that come afterwards, all right? So that's going to be, for example, the mesh3, and then the nickname is going to be dm3, and then the converted the mesh3 object, for example. And then this is also going to be of the type item. Okay, beautiful. And then in solve instance, I would like to do something very similar to what we have here. So I would like to create a mesh from all this stuff here. So to start with, I think what we will need to do is we will need to basically get the data. So that's going to be, for example, the mesh is going to start as a new mesh, or it's going to be null, for example. And then if, what were we doing here? I forget what were we doing. DA get data. So we're going to get the data from index 0, and ref is going to be the mesh. All right. All right, beautiful. So once we have the mesh, I want to turn the mesh into a dmesh3 object. What I would actually like to do is, since I already have the function here that I created before in the previous video, why don't I just copy and paste this directly? Because this is the beautiful thing about making functions for things, that then the code becomes very reusable and very encapsulated. So I'm going to copy this function here, and I'm going to add it right here. So I'm going to have a function. This is going to be also protected. It's going to be part of this component, all right? And it's going to be a function that takes a mesh and turns it into a dmesh3. And as you can see right now, this is complaining big time because it doesn't understand what a dmesh3 object is. It's not part of the API. So at this point is when we need to make our project aware of the existence of this new object called a dmesh3 object. How are we going to do that? We're going to do that by loading the library that we're using, the Geometry 3 library, into our Visual Studio project. So if I go to my Grasshopper plugin, to the actual files that we have here, you can see that I have the project files, and then I have a bunch of folders, and now I have mesh components, and I have the C# file that I'm working on, etc., etc. A very common method for managing libraries in your projects that you're managing manually, because remember, we're not using NuGet packages or anything, we just straight up managing our own library, is basically to create a folder. I'm going to call this libraries, and then just copy pasting there all the files that we're using that we're referencing in our project. If you remember from the previous video, what I did was I downloaded from the Geometry 3 library, I downloaded the project, and then I built the DLL myself. So I do have the DLL somewhere in my system, and therefore I'm just going to copy paste the DLL right there, okay? And as you can see, this DLL is now showing up here. Sorry, is now showing up here, correct? But I still get the same error. So the only thing that's changing is that I do have access. I can see my folder, my library here. The problem is that my Visual Studio project is not aware that this library should be loaded as part of code that should be available in the project. So the next step that I need to do is I need to go to dependencies, and I need to go to assemblies. And this part here is where in my Visual Studio project, I make the project aware of all the things that I want to have available code-wise in my project. So what I'm going to do here is in dependencies, I'm going to add the assembly reference to my project. Okay? So I right click on dependencies, I do assembly reference, and then instead of using any of the standard .NET framework dependencies, what I want is a manual, to load a manual file. So what I'm going to do is I'm going to browse, and then I'm going to click here on browse, and I'm going to go to where my project is. So that's going to be on my desktop. I have a link to the parametric camp. No, what is this? Sorry, let me take a second here. Where was this? Sorry. Yes, it was in my desktop here on the parametric camp plugin, and you can see that there's libraries, and then there is the Geometry 3 library. As I double click there and I click OK, you can see that Geometry 3 is now available in my project, which is great, right? But I'm still getting the same problem here. So what do I do now? Well, the only thing that I need to do is I need to remember that I need to make that library accessible and available in the file that I'm working with. If you remember in C# scripting, we did the import the library using the using keyword. So we're going to do the same here. We're just going to say, I want to use G3. And you can see how the namespace already shows up because it's available here. So G3. And as I do that, hopefully these errors have gone. Okay. And then I'm just going to remove that, which was an error, okay? And you can see that now I have the function that takes a mesh and converts it into a dmesh3, correct? Beautiful. So that's pretty much it. That's how you load a library in Grasshopper. So, that's how you load a library when you're building an actual native plugin in Grasshopper. So I'm going to finish building these components and then we're going to talk by the end of the video on issues of distribution and issues of licensing. But let me get and finish, let me build this, So I'm going to say, for example, dmesh, I'm going to build a component. So dmesh3 is going to be convert mesh, and that's going to be the mesh that I took in. And then, for example, set data and parameter index object data is going to be dmesh3. All right. And I'm going to save this. I'm going to kickstart. I'm going to run the project. And if you remember from previous videos, I had linked it so that it dynamically now loads a file that I'm using as a test bench called components, right? And with my file attached. And you can see that if I now go to, where did I have this? Pcamp, all right? If I now go to mesh, you can see mesh to dmesh3, all right? And then I guess we have to load a mesh here. So can I copy this into my components somewhere here? All right, and then can I, can I load a, I'm a little rusty as of the recording of this video. Can I load that mesh here? And then I'm going to hide it. And then I'm going to plug it in here. And you can see that if I plug a panel now, you can see that this is a native object of the type G3 mesh3, which is great. Now it's working fantastically. Okay, beautiful. So let me quickly build those two other components that we were missing. I'm going to do this offline and I'm going to show you what it looks like right now. Okay, so let's just do that offline because we want to keep that video short. So mesh to mesh3. So I guess the next thing we want to do is we're going to do the opposite. So I guess we're going to make a function here. Okay, so we're going to make a function here. Okay, so mesh to D3 mesh, new item. And then we're going to call this, what are we going to call this? dmesh3 to mesh. And then we're going to, dmesh3 to mesh. And then dm3 to m. And then converts a dmesh3 object to a grasshopper mesh. Category is going to be pcamp, and subcategory is going to be mesh. And then in the input parameter, pmanager, add a generic parameter, and I will have to explain that. Add generic parameters. And then this is going to be a dmesh3, nickname dm3, and then input input dmesh3, and then this is going to be item, and then the output is going to be pmanager.add mesh parameter, mesh, this is going to be m, and it's going to be a grasshopper mesh, and it's going to be the type item. Okay, and solve instance, I'm going to do protected. Actually, you know what? Protected mesh, convert mesh, dmesh3, dmesh3. dm. And then I have to also import here using G3, the mesh. Okay, protected, convert mesh, and then return m. Okay. Hey Jay, how are you doing, sir? And then here in instances, this is going to be a null. And then here I'm going to do da.getData, and that's going to be 0. And that's going to be dm. And then mesh m is going to be convert mesh dm. How did I do it in the other one? Convert mesh, yes. And then da dot set data 0 mesh, correct? And then that should work, or maybe not, because what I'm getting from the generic object is an object. I may have to do some casting here. Let me see if that works. And it doesn't work. I get an error. What is going on? System null. Okay. All right. So if this didn't work, then return. Okay. And so let's try this now. All right. Components. Okay, and then I should be able now to take the dmesh to mesh and reconvert this to a regular mesh, correct? And it looks like it's working. So this and this and this. Okay, fantastic. So that's working. So then something that I don't need to address is I will need to address a generic parameter. No, something that I don't need to address is the generic parameter, because this gets, apparently this gets automatically handled, which is great. Gets automatically handled, so we got that. All right, and then the next one that we're going to do is going to be mesh remesh. Okay. All right. And then we're going to turn this into a function. We're going to turn this into a function, and then we're going to make a new component, new item. That's going to be this, and it's going to be called it's going to be remesh. My components, and what are the inputs? Target, edge length, and passes. My component, remesh, and remesh description. Remeshes a mesh 3 object to a target edge length. Category is going to be pcamp, subcategory is going to be mesh, and then in the inputs I'm going to add pmanager.add generic parameter. That's going to be a dmesh3, that's going to be dm3, and I'm a little lazy, so I'm going to not, well, I should not be lazy. Let's do it the right way. Input dmesh, and then pmanager add, for example, what are we going to do? Target length, that's going to be a number. So that's going to be target edge length. And then this is going to be L, and this is going to be target approximate target length for mesh edges. And then parameter access item. Beautiful. And then p manager is going to be add integer, and that's going to be passes, and that's going to be uppercase P, and then number of passes, computation passes, for example. And then this is also of the type item. All right. And then the output is going to be pmanager add generic, that's going to be what? dmesh3, and then also dm3, remeshed mesh. And this is going to be item. Okay, we're going to do that. We're going to solve the instance, and then we're going to add here a protected method, which is going to return a dmesh3 object that we haven't imported yet. So using g3 dmesh3 remesh, and then we're going to take a dmesh3 object dm. We're going to take a target length, and then int passes. And we're going to copy this. This is going to be dmesh, and that's going to be dmesh. This is going to be target length, the copy, and then return the copy. We're going to return the new dmesh object. And what is wrong with this? Remember, names cannot be the same as their enclosing type. Oh boy, remesh to target length, target edge length, for example. Okay, beautiful. Then once we have that, we just need to load the inputs, right? So that's going to be, yes, Abar, don't worry. I'm actually doing this very fast just because I've done it before in previous videos. But if you follow the videos, you will understand what I'm doing. So just put a pin on this one, and then just go through the full playlist, and then you will get connected to what I'm doing and what I'm doing right now and why. So dmesh3, dm is going to be null, and then double target length is 0, integer passes 1, and then if we don't get data from the input 0 that goes to DM, then return. If we don't get data from 1 and we reference it into target length, then also return. And then if if we don't get data from the third input, which should be stored in the variable passes, then also stop doing anything. And then once you've done that, remesh. I want to remesh, and then remesh to target length, and then DM target length and passes. And then da.set data 0, the remeshed. Okay, beautiful. Shall we try and see if this works? AABB. Thank you very much. Then just share some of the toolbox with the world. Post it on Discord. Come to Discord and put it here on work sharing and share the love, you know? I'm following up for my cell phone. Couldn't miss today, but chatting for my cell phone. Good to see you, Mehrad. Okay, and then we go here, nerves, remesh, and then we're gonna take the mesh, which was here. We take the mesh, we take the mesh, we take the mesh components. We're gonna take these two. We're going to paste them somewhere here. No? Yes, somewhere here. Target length, target. Can I display these full names? Yes. Okay. And you can see that now the mesh has been remeshed and we get the same result. Yes. Yes, it works. Fantastic. Beautiful. So, one thing to consider. So now I'm going to explain this in the video. So I'm going to explain this in the video. I may want to actually wait. Can I drag these two together? Yes. And this is going to be target length. Oh, this is going to be okay. All right. And then I'm going to start the video. I'm going to continue the video. I'm going to go back to, I did mesh to the mesh. Then I did the opposite. I convert to the mesh. And I want to highlight that I need to input a generic parameter and then remesh an input parameter, number, etc., etc. And then I did the remeshing in this function. And then what I would like to do now is I would actually like to move these to their own class, which is kind of interesting to keep things tidy. So I will talk about that in a second. Nice. So we implemented this and it's working. There was a lot of typing going on, so I saved this from you, the viewer, right now. But if you want to see how I actually typed all of this and how I wrote it, there should be a link to the live stream where I was recording this video. It should be popping as a card or somewhere over there, or there should be a link here in the description of this video. Okay? So what you can see is that I have mimicked what we used to have in the other example, But what I've done is I took a mesh, then I am converting it to a dmesh3 object, then I am doing the remeshing based on some target length, and then I'm converting the dmesh3 object back into a mesh that I can render inside of Grasshopper, and I can further operate, 3D print, whatever. And you can see that it's kind of working because the remeshing now from the original mesh is giving me more vertices and more faces. Okay, you can see there's like a clear kind of difference between the original one and the one with the faces, the edges that are much shorter. Okay, so how have I done this? Basically, I created the mesh to the 3 mesh component that you already saw. Then I created the inverse, which was a component that takes a D mesh 3 object and turns it into a mesh. This is getting very complicated. And the only thing that I would like to highlight here is that remember that just like the output here was a generic object, because Grasshopper does not understand, does not have an API for the mesh 3 objects, the input here must be a generic one. And the output was a regular mesh. And I also did the conversion by creating this one function that takes a dmesh3 objects and return a regular one. And it does the conversion using the vertices and using the faces. And then, yeah, for the remeshing, I followed a very, very similar logic. I created a component with a generic input for the dmesh3, number and integer, and then a generic output for the dmesh3. Everything that is not native Grasshopper components, they need to be handled, the inputs and the outputs, with generic parameters. And then I also encapsulated everything that was the remeshing operation inside of a function. Okay? And then the component, the solver, was just basically simply loading the inputs and then remeshing the mesh and outputting it in by the output. Okay? So if you want to learn more again about how I do this, watch the live stream or just take a look at the code, which will be, there will be a link published to the source code in the description of this video, okay, in our GitHub repository. Okay, so and I need to think what we're gonna do now. So when I publish this in binary in debug and .NET4, we get this, and this is getting loaded because probably Grasshopper developer settings, I am loading this. Yes, I am loading this. Okay, fantastic. So I want to talk about that. I want to talk about how, when we do that in the folder, in the bin. Now I want to talk about file management. And I want to talk about how whenever we compile, it just gets distributed and it gets copied here. Uh-huh. Okay. Okay. All right. AAB, yes. You're welcome to share anything that is nerdy and cool. You're welcome to share it in the Discord with us. This is similar to the mesh machine component that comes in Kangaroo 00. I guess I'm not familiar with that component, but yes, it's probably similar. All right. For example, let's go to Grasshopper folders, components, and then, for example, Remo Sharp, mesh edit. All right, I should remember this. Mm-mm-mm. Now, one topic that I need to address that is very important is now, how do you actually distribute this? Because when this building a plugin works, because when you hit play and you hit execute, what happens is that you're basically in your project folder, you're basically building this file called the GHA file, which is the file that you distribute as your plugin, which I'm not sure if we have talked about this, but we will talk about this in a second, all right, in further videos. But this also works because something that is happening is that your Visual Studio project, when it produces this Grasshopper GHA file, which is your plugin, right? It's also doing this operation where next to the file, it's copying the Geometry 3 DLL that is a dependency of our project. And this is very important for you to keep in mind, because if you're building a plugin, you probably intend to distribute this plugin to people in the world at some point, right? So because you're now using an external library, a third-party library, to power some of the operations that you're doing, you need to remember, and this is super important, you need to remember that with the distribution of your plugin file, you also has to distribute the DLL file, because you cannot assume that this DLL will be available to whoever downloads this plugin and uses it in their own computers. There is a very, very strong likelihood that that will not be the case. So that's why, remember, whenever you distribute or you package this into a zip file or you upload it to Yak for people to download, you need to include any DLLs that your project depends on. And this is the reason why, for example, if you go to Grasshopper, this is, for example, my Grasshopper libraries in my computer. You can see that if you go to Millipede, there's a ton of DLL libraries. If you go to Mesh Edit, there's a bunch of DLL libraries too. If you go to Firefly, there's a lot of DLLs, because all these plugins are loading libraries to power and to fuel some of the work that they do. Okay, so remember, if you use third-party libraries, you need to bundle them with your plugin. Which leads me to the next consideration that is very important to keep in mind here. When you distribute code, you need to make sure that you have the permission and the rights to do that distribution. Because we are working in a community where a lot of us support open source code and free distribution of code, etc., etc. But we need to make sure that if we do that, we do it legally and we do it with the consent of the people who have made that code available for us. So for example, a case for this particular example that we did is that if we go to the GitHub repo of Geometry 3 Sharp, which is the library that we are loading, we need to make sure that we can distribute this file with our plugin. We first need to make sure that that's possible. So the first thing that I would look is I would go to the license file and I would read what kind of permissions do I have with this license. And you can see that if I read through the code, it says me like permission is granted free of charge to anyone with a copy, blah, 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 to use, reproduce, display, and distribute. All of these are the ones that we're interested in, the software, and to prepare derivative works and to permit third parties, blah, 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 subject to the following. The copyright notes of this environment, blah, 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 needs to be distributed with your plugin, with your software. All right, so this is great. So as a summary, I can use it for commercial, modified, distributed, and private use. No guarantees of any kind, but so long as I distribute it with a copyright notice, this one here. All right? So if I want to do things the right, good way, what I need to do is I need to make sure that with my plugin and with my files, I also include the license of this Geometry 3 library. The way to do that is very easy. I can just go here to the raw file. I can copy all this code. And then here, I'm going to write a new text document. I'm going to call it geometry3 underscore license. Okay. And I'm going to open a new, I'm going to open it in a text editor, for example. I'm just going to drag it here. And then I'm going to paste that license there. And even if I included a link, that would probably be nice, like a link to the repo. I'm just going to do that. Why not? Where am I? I'm just going to make sure that yes, here, and then there you go. Why not? Okay. And that's it. And now, whenever I say, okay, I'm ready to share this with the world, I'm gonna make a zip file. I need to make sure that the zip file includes at least all of this, which is, uh, for example, this is the pcamp plugin, which includes the DLL, the license, and the plugin file. All right. This would be the right legal and ethical way of doing this. Just make sure that whenever you distribute and share DLLs or code, you have the permissions to do that. And if the author asks you to do anything with that, just make sure that you distribute, for example, this is a very common thing, to distribute the copyright notice with your plugins. Okay? Beautiful. Alrighty, so we can now use third-party libraries in our Grasshopper plugins. And this is actually a very common thing because there's a ton of DLLs out there that are super useful, a lot of fun, and by wrapping them in Grasshopper components, it's a very easy and very useful way of providing people in Grasshopper with the possibility of using things that other people have coded for other platforms, okay? So if you want to write a Grasshopper plugin that is basically a port of someone else's DLL, it's a very common and very easy thing to do. Okay, fantastic. So I think that was it for this video. Thank you very much for watching. If you found this useful, you know, click, 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 like, comment, 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 say hi, and all those things. And see you on the next video on this series, where I believe we're going to take a look at a very nifty... Wait, I forgot to do something. I forgot to do something. Wait. How are we going to do this? No, I forgot to do something. How are we going to do this? How are we going to change the video now? That's a kind of a bummer. Okay, so we're not going to do that. Okay. Yes, sorry, I forgot I wanted to do something in this video, but since I'm already done, it's going to be a little disruptive to now do it now. So I'm going to include a tiny bit of code that I wanted to explain in the next video when we talk about sharing data between components, like a very nifty and interesting technique that you're going to enjoy. Okay? All right, fantastic. See you in a bit. Bye-bye. Okay, so now we're going to record the introduction. Sorry. All right. Hello, how are you doing? This is Jose Luis here at Parametric Camp, and welcome to another video in our series, Advanced Development in Grasshopper. In this video, what I would like to teach you is how to include and how to work with third-party libraries inside of your native Grasshopper plugins in a very, very similar way to what we did in a previous video where we loaded external libraries in C# script components, and we were therefore able to power our code with the code that other people have written for us. So in the example that I'm going to do here, I have an input mesh that is a grasshopper mesh, and then I'm going to convert it to a mesh 3, dmesh 3 object from this external library called geometry 3 sharp that has a lot of interesting properties and a lot of interesting functions to do mesh manipulation. So you're going to see that I'm going to convert it into that kind of mesh, and then I'm going to do a remeshing process that is going to allow me to remesh the mesh so that all the edges have a length that is very close to a target length. So you can see that it allows me to fine tune all those vertices, all those meshes, and I think I just broke. Look at this remesh, and it's very, very nice, right? Beautiful. So the way this is going to look is that I'm going to add these new 3 components, right? And then I'm going to explain a few things, such as, for example, how to work with a generic parameter, which I don't think we've seen so far, and how to encapsulate data and functionality inside of functions, just to make your code cleaner, more reusable, and then easier to work with in the future. All right? Beautiful. So let's get started. All right. Okay, so I'm going to save this, but I'm going to put this back here. Yes, I'm going to save this. I'm going to close this, and I'm going to close this as well. And um, I'm going to take a tiny break, and then I'm going to spend a few minutes answering questions and hanging out with you. Before we go, I'm going to do the next video, I think. We're going to try the next video. Oh, is this up? Yeah, the green screen is not fully. There you go. Okay. And all right. Can you let me take a quick bio break and I'll be right back? I'll be right back, and then we will record the next video where we want to make a logger for a component. That's going to be super, super cool. Let me show you how that works. All righty. All righty. Um, Okay. And I see AABB, who on Discord is Ozax, um, just has shared like a bunch of subdivision curves as a plugin. That's very nice. I do want to say though, AABB or Ozax, people who use very, very different names on chat and on the Discord, it's hard for me to track who each person is sometimes. So my invitation is that you try to have names that are a bit more consistent so that I know who you are. Otherwise, you can do, of course, whatever you want, obviously. And okay. And Abbar had a question. I had a question. Working with nerves and grasshopper is easier than working with mesh, but when I have mesh definition, I get more speed with the sliders. Yes, that's true, because at the end of the day, nerves are mathematical entities, and every graphics, computer graphics software needs to end up doing a conversion to mesh so that it can actually show up on your screen. So even if you're working with meshes theoretically in Rhino, what happens is that for Rhino to show you that mesh on your screen, what it does is it does a process of meshing it very, very fine so that you see like a nice curvature. And that process is actually quite expensive. Working with meshes is not expensive, with a lot of exceptions right there, but it's mostly the process of meshing them to render them on your screen that is typically taxing um, from a computational, from a resource standpoint. So, but you're right that nerves typically give you more flexibility for modeling, if that's what you're interested in. I keep looking at myself. I need to get a haircut, clearly. Good book on the logic behind meshes. That is true. I have not found a good book on meshes. The closest I can recommend. Can I recommend a book? Let me look it up. Um, Kyle Steinfeld, Geometric Foundations. Is that correct? Yeah. I really like this book. It's by Kyle Steinfeld, professor at UC Berkeley. It's basically about computational design in general. I do believe it does have a chapter on meshes, although it's not the main topic of the book. But I have to say the book is extremely nicely written and illustrated. It's a very, and it's very thorough in many aspects. So it has like beautiful illustrations, graphics, etc., etc. I strongly recommend you get your hands on it if you can. Okay. Unfortunately, most of the examples are written in Python. So, but it's okay because the concepts are what matter at the end of the day. And someone, what about subdia nerves? What do you mean about subdia nerves? Merad? Uh, eh, Sir, why is it super hard to edit mesh in Rhino when we compare it to other forms of software like SketchUp or Blender? Because Rhino is very much optimized for nerves. That's what they're good at. That's what their value proposition is. So even though they support meshes, it's not really their main topic of interest, if you will. So they have not included additional tools to make mesh manipulation easier, more fluid, etc., etc. And there's also something inherently more fluid and flexible about working with nerves than it is with meshes. So it is what it is. But SketchUp and Blender are more mesh oriented, and that's why they have better tools for that. Can you please make a video on how to use OpenAI in Android Studio for Java? I wish I would, Mr. Hunza. But I haven't done Android development in years, and I kind of want to move on from OpenAI because we have a lot of work to do. As you have seen in the beginning of the video, we have a lot of homework for 2023. So I don't think we're going to do Java anytime soon. But we could do processing, perhaps. Can we do processing? Can we do, yeah, HTTP requests and processing are actually quite straightforward, so I don't see why not. Why do I make fun of the P language? Wow, Jay, that's the elephant in the room, huh? I make fun of the P language because there is a running joke out there in the wild that I do not like the P language, and that, what is the running joke? Yeah, that I don't like the P language. And I kind of find it funny, and I decided to go along with the joke. And the it's not true. It's not that I don't like it. It is true that I don't use it a lot just because I want to focus on computational design environments, and Python is a very good scripting language, but it's not one that integrates well in the typical computational design frameworks that I use. So I basically only use it when I'm doing machine learning, which is by far the dominant language. And yeah, but I'm fine with the P language. It's just that people now believe that I hate it, and I kind of find it funny. So I'm okay perpetuating the joke, if you will. Yes, sir. Processing is fun. I know it's fun. I love it myself too. All right. So, so what are we going to do now? We're going to share data between components. How awesome is that? Huh? Uh-huh. How are we going to do that? How are we going to do that? Mm, a bar, C sharp or Python? Wow, another elephant in the room. So the real answer is that it doesn't really matter. The real answer is that you should focus on becoming better at writing computer code if that's what you're interested in as a designer. And the reality is that once you learn in general how to code, you will find that writing C sharp or writing Python, they're basically, they have the same features. They're very similar languages with a few things here and there. And that once you get good at one, it's very easy to jump to the other one. So it's up to you. If you think you're going to stay in the nearby future, in the Grasshopper, Unity kind of world, then C sharp is probably better for you. If you think you're going to do a lot of machine learning, then probably Python is a good choice. If you think you're going to do a lot of web development, then I would definitely go for JavaScript, for example. So it's up to you. Okay, and I'm going to, yes, I use mostly C sharp these days because I integrate really a lot with these tools. And I like JavaScript a lot because I like web a lot. I like making things that you can just put online. People go to a browser, they use them, and bam. You know, I like doing that a lot too. Okay, so I want to record a quick video now on showing how we can share data across components. And this is very useful, for example, for debugging. And I want to take a look at how I've done that in the past to refresh my memory. Uh, So where do I have that? Wow, I guess I could probably show you. So I remember I did that in the Machina for Grasshopper project. So we probably want to take a look at this. The bridge, motion update, connect. No, this doesn't have a debugger. It does have a logger. This has an auto update. Because it comes from the logger. Yeah, that's a lot. I don't know how to do that. Okay. So I guess I'm gonna have to look somewhere else. I do have a project, but I did that, but I can't show it. So let me check that internally very quickly. Okay. Uh-huh. Okay. Utilities. Okay. No, no, no. Wait, that's not how it works. No. Uh, um, components. I guess I can just try real quick then. Let me just try real quick to do what I want to do. So I'm just going to prototype something real quick here. So utilities is going to be, for example, I'm going to write here a new, I'm going to call this logger. And then I'm going to create a new class that is just going to be a simple class. Log. So yeah, I'm going to call this log. And I'm going to make this a public static class called log. This thing is going to have a list of strings, lines. It's going to be a new list of strings, and it's going to be private. And then what? It has to be static, of course. It has to be static because it's a static class, and then I'm going to static void. I'm writing this real quick, but I will explain in a second what I want to do. And then lines dot add line, and then static list of strings. And then what do I want to do? Get read, and then for example, and then I'm going to return these dot lines. I'm going to return lines, for example. Okay. Yes, and then the logger is basically going to do nothing, and then it's going to p manager add p manager dot add boolean parameter update and then empty and then item. I'm going to explain this in a second. I'm just prototyping it right now real quick, and then add a text parameter is going to be logs, and then L, and then this is probably going to be this, and then grasshopper. I guess we probably want to make this a list. Yes. Okay, solve instance, boom. Boolean update equals false, and then da dot if don't get da bit get data from 0 reference update, and then return. All right, and then we're going to get log is going to be log, which we need, yes, we need to make this public, and we need to also make this public so that it's available here dot log dot read. and then va.set data list 0 log. Okay. And then we need to do some kind of logging. For example, in remesh here, string message is going to be mesh remeshed to, for example, v, and then remesh.vertex count, and then plus, and then face remesh.face triangle count, and then log.add. Why do I not have, because I'm not, because I guess I need to load from the dependencies. I need to go to utils. Whoops, sorry. I need to go to utilities dot log dot add dot message. Okay, and let's see if this works. Okay, so let's say that I drop here on utilities up. Oh, because I haven't properly, I probably was sloppy. Yes, exactly. Description, no description, and then pcam, and then utilities, for example. And that's why I was just showing whatever. Okay, utilities, logger. Boolean toggle. Okay, so all right, so for example, and then I get 8 here, and then I get 6, and I get 4. And okay, and every time it has been remeshed. So basically what I could do here is oh, and I need to change the updating. And probably I can just do a timer here, a trigger. But I can do 1 second, right? And then, right? Oh, yes, very good. I love it. Okay, so it works. So I guess I'm going to now delete it and I'm going to do it in, I'm going to do it in, and I'm going to just write it again, I guess. This, yes, it will be deleted permanently, and logger, I want to delete permanently as well. And then in remeshing, we probably want to remove this. Okay. And all right, so how are we going to make this video? I'm going to record, I did record into, okay. So what we're going to do is in the intro, I will talk about how to share data between components. And then I will say that we're going to write a logger component, like a debug, like a console. I'm going to call it console. I'm going to call it P console, for example. I'm going to call it the P console. And I'm going to call it a P console. Yes, that sounds about right. And I'm going to show how yes, and I'm going to show how we can use, but the whole point that I want to make is that we can use standard C# development techniques, even though these components are basically like this super empowered class that we haven't really broken down yet. Okay. And then once I start, what I would like to start is by making a case about, yes, we're writing these components, they inherit, and they're basically inheriting from a subclass, but we can use all the techniques. So what I want to do is I want to have a component that serves as a console and that prints out information that is happening in other components, for example. And I'm going to make it static so that is shared amongst all instances. There's only one per project. Okay. All right. Okay, let's do that. Sounds good. Let's start with the basics. So as we have been developing all these components that you can see here, you can see that the basic thing that we have done is that we have gone to add, we created a new item, and for every component, we basically use this empty grasshopper template, which we kind of gave a little bit for granted. And there's a lot of already pre-filled code here, etc., that we haven't really broken down. But the point that I would like to make in this video is that everything that we're doing basically conforms to standard practices in writing C# code in the .NET framework. What that means is that when we create a component, what we're basically doing is we're using a template that is creating a new class, and that class is inheriting of a, let's say, a larger template class that is called the GH component that already has and comes with a lot of functionality to make sure that the component shows up in the screen, that has inputs, that has outputs, that is connected to the engine in Grasshopper that makes component update, etc. And then our only task here is to basically fill in the gaps of how do we start the component, how do we add inputs, how do we add outputs, and how do we write the code that is supposed to execute inside of this component to make all the goodness that we want. All right, that is basically what we've been doing throughout all this playlist. But what I want to say is that even though we're basically using most of the time this super empowered template for Grasshopper component development, we don't have to only use that. We can combine the code that we write in our plugin with standard practices that we use whenever we write other types of code libraries, such as, for example, repositories of code, such as, I don't know, plugins for other environments, etc. So this example that I would like to do in this video is an example where we're going to combine the technique of, for example, keeping track of data in a static way across the entire library using static classes. And we're going to mix match that with this standard practice of just building a library by adding components. Okay? So how am I going to do that? I'm basically, well, first of all, let me remove this component that I just created empty, right? And then what I would like to do is I would like to create a component that is going to be called the P console. It's going to act as a console, very similar to when we say console write line, all right? And then something shows up in the screen when we're writing console applications. What I would like to do is I would like to mimic that feeling, but inside of our Grasshopper library. And then what I would like to do is have one component that will be the P console and that will output all that text. And what I would like to do is connect that component, that one single component, to all the other components and have those components be able to stream and output internal data to that component, all right? So how am I going to do that? Well, the way I'm going to do that is by first, I'm going to create some kind of, I'm going to call this abstract, but not in a CS, not in a computer science term. I'm going to create some kind of independent console object that is going to be part of my library that I'm going to call the P console, and that is going to be the one that is going to manage getting data from other components, and that is going to manage offering that data back to whoever is asking for it. All right? So hear me out on this one. So I'm going to go here to utilities, which was that internal section that we had for functions that were not exactly components, basically. So I'm going to go here and I'm going to add a new item over there. But instead of using an entry Grasshopper component, I'm going to use a standard class, like nothing fancy, all right? Nothing with that structure. And I'm going to call this the P console, correct? And as I do that, you can see that I have a standard console, doesn't inherit from anything. It's just a very, very simple class, all right? So what am I going to do? I'm going to use standard techniques to mimic the behavior of a console. So what is that going to look like? Well, what I'm going to do is I'm going to create a class that is going to store a list of strings, a list of text, so that if at some point anyone asks for the output of that console, I can just give them all the text that anyone has printed to the console. So the first thing that I'm going to do is I'm going to declare an internal variable that I'm going to call the logs, and I'm going to initialize to empty. All right. So that's going to be a list that is going to accumulate anything. I'm going to call these lines actually. Anything that accumulates whoever prints here. Then the next thing is I'm going to create a method, and that method is going to be a method that anyone who uses the P console can use to write to the console. I'm going to call it write line, just to really mimic the feeling of C#, okay? So I'm going to create a void method that is going to call write line, excuse me, and then it's going to take an input as a line, all right, as a string. And then what I'm going to do is, whenever someone does that, I'm just going to add that line to my memory, the memory of the console, if you will, which is basically this list that keeps adding. And then I'm also going to create another function that is going to be something like read or something like that. I'm actually going to call it read. And then what I'm going to do is anytime someone asks for this, someone wants to read from the console, I'm just going to return all those lines that have been accumulated. All right? Fantastic. So this is basically a really, really simple implementation of a console object. Now, what I would like to do, this is not done yet for the reasons that I will explain in a second. So what I would like to do now is I'm going to go to remesh, okay? And I'm going to say, remesh is a very complicated operation. I kind of want to get track of what's going on and I want to print that to the console, okay? So what am I going to do? What I could do is I could say, well, first, let me compose a message that is going to say something like this. Remeshed mesh two vertices, for example, and then remesh dot vertex count, and then plus, and then faces, and that's going to be remesh dot triangle count. All right. So I'm going to create basically a message that I want to print to some kind of console. Okay. And now I would like to print or to write line this to that console. So now here's where the problem and where the interesting trick is going to happen. If I were to say P console, you can see that I already don't have a P console. Okay, so it's not working. There's nothing such as the P console available here, which is kind of strange. The reason why is that P console belongs to this namespace, which we have not imported. So let me go to Remesh and make sure that we are using that namespace. Okay, so that we're loading everything that is part of utilities here. All right, so that's one thing. If I go back down and then I try again, P console, you can see that now it's an object that is available. But if I click dot, I don't have access to write line, which is kind of strange. Maybe the reason for that is that the class is not public. So let me make all of this publicly available. The class, and let me make also the two functions write line and read, let me make them available. So then let me try again. P console dot, and then, oh, but I still don't have a write line. Why do I not have write line? Well, the reason is that because of how I have designed the console, right now the console is a standard class that basically uses, basically in order to use it, what I need to do is I need to instantiate objects of this class that then I can use to write line and to read stuff. What that means is that because it is a standard class, what I will need to do is I will need to create pconsole objects by doing this. For example, let me say var pconsole is going to be a new pconsole object, right? And then once I have created an instance of that, then I can do pconsole dot and write line, and I can write my message over there. Okay. Now this maybe feels like it will do the trick, but it will not do the trick. It will not work for the reasons that I'm going to explain very soon. Okay. So, but before I get into why this is not working, let me first make the component that will output that logger to the screen. Okay. So for example, I'm going to go to utility components. I'm going to add a new item. This one is going to be a Grasshopper component that I'm going to call a pconsole logger, for example. The pconsole logger, and then I'm just going to add here to the category pcamp, and then here utilities. All right. It's going to have an input. For example, let's say that we want to add a Boolean that is going to be called update. So if we don't update, we just don't want anything to show up from the console. That's going to be no description, and then Grasshopper parameter access is going to be item. And then the output will need to be of the type text, and it will need to be a list because we may want to output a lot of text from there. So pmanager dot add text parameter dot logs, and then that's going to be L. I'm not going to add a description, and the parameter access is going to be, this one is going to be of the type list, okay? Because the console may give me a ton of text. And then I'm going to do the standard thing where I'm going to retrieve the Boolean. So I'm going to initialize it to false. And then if I don't get it, if I don't get the data that I reference into the update component, then stop executing this component, all right? And then if update is false, then also stop, like don't output anything, all right? But if the output is true, then I actually want to output something. So I'm going to say, let me read logs. Let me read them from the pconsole object. So, okay, so I guess we're going to have to do the same thing again. We're going to go here to pcamp, utilities, etc. We're going to add it here. So now we do have access to the pconsole object, but Remember, we don't, so I guess we need to initialize this. So I'm going to create an object of the PyP console. It's going to be a new instance. And then from this instance, I'm going to read the text, all the logs, and then I'm going to output those logs. So da.setDataList, the first output, and all those logs. Okay, beautiful. So it feels like this should work, but it's not going to work. Let me show you why. So I'm going to save everything. I did add the output here to the to the console, etc. And yes, so this is, let me just load the plugin and see if this works or it doesn't. Okay, I'm going to load the components. All right. Okay, so I'm going to go to pcamp, I'm going to go to utilities, and I'm going to the pconsole logger. All right, I'm going to plug here a panel, and I'm going to press here, put here a Boolean toggle. All right, and I'm going to say true. So this should be now updating, right? And so it's not working, but let me see. Let me change this so that I make modifications and I force this component to update a bunch of times. This component has updated several times as I was changing my slider. So I should be getting here like a bunch of those updates, right? But I'm not getting them. So, okay, so this is not working. So why is this not working? Well, the reason why this is not working is because of this way of working with the console. If you remember, the console object, when we're writing console applications, is this one object that is called console, that we don't have to instantiate, that we don't have to create with the new keyword, etc., because it is one common object that is available to any single part of the code that lives in a console application. It's the same object. And because it is the same object, and because it's accessible to everyone, whoever writes to that console ends up in the same place. There's the idea here that that is a unique object that is the same for everyone who is writing something to the console in a console application. That is very different from what we've done here. Because pconsole, because of the nature of this class, because pconsole needs to be instantiated, then what it means is that every time I update the mesh, I create a new instance of a console, I write to this console, but then probably when this function ends, this pconsole object ceases to exist. It expires. It's not available anymore. And on top of that, the problem is also that in my pconsole logger, what I'm doing is I am actually creating a different copy of the console that is not the same console as the console that the remesher is using. They're different objects. So even if these two theoretically were updating exactly at the same time, which is never going to happen, but even if that was the case, they are still two tiny independent consoles that don't share the same data with each other. So that's why even if I read from here, I get nothing because this object was created right away, was not interacted with by anyone, and then this was just empty. All right? So how do we fix this problem? Well, we use a technique that is very common in computer programming, especially in C#, when we want to share data amongst different processes, which is going to the pconsole object, and then instead of making it a class that needs to be instantiated into objects for those objects to work, what we can do is we can create a static class. I don't know if I have talked about static classes in my C# course in this channel, but if I have, there will be a card popping up on the corner if I've done this. If I have not, then there will be no card or no description in the video, and maybe I have to do this in the future. I forget, okay? But the idea is that static classes are classes that already exist as entities when you define them, and their properties, their static properties, are already available as well without the need for instantiating them. It's basically saying I'm going to create a one-off, but that one-off, as I declare it, it already exists and it's the same for everyone who wants to interact with it. Okay? So, how does this look like? I'm going to add here the word static, all right? And then basically, I'm going to make every single thing that lives in this class also static. The static property, static function, etc. All right? What this means now is that pconsole cannot be instantiated. I cannot create a new pconsole. And actually, probably, you can see that this is already giving me an error because look at this, cannot create an instance of the static class pconsole. Pconsole is just one of, all right? But the beauty of this is that now what I can say is like, well, you know what? I'm going to get rid of this. And then this thing, instead of being, it's going to be the pconsole object itself. Very, very similar to what we were doing in console applications. And this one here, same thing. For the logger, I get rid of this. And then what I want here is just to read from that same pconsole application. Sorry, class. All right. The beauty of this is that there is only one pconsole class. It is static. It's the same for everyone. Everyone in this entire library, in this entire plugin, has access to pconsole because it's a shared one and it's unique. All right. So whatever someone writes to the pconsole, for example, remeshing, will be available to be read from anyone else, such as, for example, the logger. All right. So are you ready for this? So let's run this. I'm going to output this. And I'm going to load this here. All right. So is this working? Oh, let me see. So for example, I'm going to update this component a bunch, but it's not updating anything. Wait, is it not? So if I do false, but if I do true again, what? This thing shows up here. Okay. Wait. What happened there? Jose Luis, do it again. So I'm going to update this component. This should be sending messages here, but it didn't. But if I turn this on and off, all those new components show up here. Oh, Jose, why is this happening? Well, it's happening because if you remember, the way Grasshopper works is that this component, it's only going to be updated, it's only going to be regenerated if any of the inputs change. And since I am changing here, this is not changing anything. This is not triggering an update. So unless I turn it on and off again, this doesn't go anywhere. So a workaround through that can be to just basically say, I'm going to plug in here a trigger, right? That trigger is going to be of 1 second. And then every time I do my modifications here, you see that thing updates automatically. That was very difficult to see. So let me show you again. So I'm going to make some changes here. Pop, 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 and then they show up over time. Every 1 second, the component updates and picks up the new data. All right. Beautiful. And no matter how many components do I have, all the components will always point to the same console object. This one, etc., etc. Something that I may want to do is I may want to add the option here to reset and clean the logger. How can I do that? Well, I can have an option here where I can say static public reset, and then whenever, or clear. I think clear is probably clearer. Clear, and then whenever I do that, then I probably want to clear the lines array. All right. And then static public void, this is going to return nothing, okay? And then in the console logger, I'm going to add an input. I'm going to call this p manager, add boolean, and then I'm going to call this clear, and then c, and then and then Grasshopper input is going to be an item. And then here, I'm going to say another input called clear. I'm going to copy and paste this. I'm going to save that here. And then what I can do is, if clear is true, then what I want to go is to the P console and to clear the console from any data. All right. I'm going to save this. And then we have now a way to empty the console object. Oh, where did this go? Would you like to see them? No, it's probably, okay. I probably just need to drop this and drop it again because it's an old P-console logger. True. And then a button here to clear. And then the updater and this here. Okay, so I have the two components. And then I'm going to change this a little bit. Boop, boop, boop. You see how that updates? And then I'm going to clear it. And then I'm going to update a little bit. Pum, pum, pum. And etc. etc. Beautiful. So we have a logging mechanism that is now dynamic, and that, interestingly, this is the coolest part. Without actually being connected to any component, it reads data that is flowing internally, let's call it that way, from the components there. I've actually used this trick a lot for debugging, for example, while I was developing for Grasshopper, and it's a very interesting one. Okay, so why not? It's always nice to have like very explicit outputs that let you know what's going on inside the platforms that we're working with. Okay, fantastic. So that was it. Remember, static classes are very useful as a way to exchange data between components and to do interoperability between different parts of a Grasshopper plugin, for example. Okay, beautiful. I think with that, this is what I wanted to cover in this video. Thank you very much for watching. If you found this useful, hit the like button, subscribe to the channel, say something in the comments, join our Discord server, share some of the work that you've done on Twitter, Instagram, whatever. You know how this works, okay? Just show a little bit of love and appreciation digitally. It helps us keep going. Thank you very much, and I'll see you on the next video in this series where, what are we going to do? I think we're going to talk a little bit about testing and debugging techniques for Grasshopper components, okay? For Grasshopper plugins. Thank you. Bye-bye. Beautiful. And now the introduction. Okay. Okay. Let me dock this a little more so that it's a little clearer. Okay. And now the introduction. This component looks so ugly, you know? All right. Let's do this. So what are we doing? We're recording the introduction to the video. Okay. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would like to show you a really nifty technique to share data and share information across different components in your Grasshopper plugin internally, all right, without having to connect them with wires. And an example that I've built in order to show you is basically some kind of console log sort of object that is basically picking up information that other components might be streaming internally. So what I've done is from the previous video where we were remeshing a mesh, I have incorporated in this component some kind of console write to our internal console a message about the operation that we just did. And what I want to show you is how, as I make this operation multiple times, what you can see is that this console is spitting out here like several messages of the success of this operation. And I can clear it and I can say just one and another one and another one and another one and many of them, and they all show up. So and these are not connected. This is happening internally. All right. So I'm using this virtual console in my plugin as a way to showcase this idea of data shared across instances of your Grasshopper components. Okay, this is going to be super easy to do, but it's also going to be a really nice way of understanding how data is managed, and also how can you use standard C# development techniques such as static classes in combination with the structures and the templates that you use to develop components in the Grasshopper plugin. Okay, so it's going to be quite nice and nerdy, and always having some kind of console for your plugin is, I think it's kind of cool. Just my opinion, all right? Okay, let's dive into it right now. Woohoo! Okay. Oh, that was a lot. Thank you everyone for staying around, sticking around. That was a lot. Okay, so Osama, can you please test the plugin to see if it works? I have never tested it on another computer. Well, I'm testing it right now. I'm not sure what you mean. Yes, and you are AABB Osax. Okay. Oh, all right. Sorry. Ooh. Jay, so Osama, if you can tell me what do you mean by testing it in another computer? I'm not sure what do you mean with that. Can you elaborate on what kind of computational design works you do? Well, I teach at Harvard University right now. I teach computational courses. We do a lot of C#, Grasshopper, and JavaScript, and servers, and some Python as well. Actually, for my HCI, my human computer interaction class. But it is loading in Grasshopper. You just saw it. No, Osama? I don't know what you mean. Like I've been loading it in Grasshopper already. What is the meaning of computational designer? What type of job do you do? What is the difference between a computational designer and a programmer? That's a good one. So I also have a personal practice. In that personal practice, for example, what I do is I sell consultancy services to people who need, I call it computational solutions to creative problems. So I develop software for people that are interested in doing creative stuff. So some of my clients are people who do fabrication. Some of my clients are people who do art. Some of my clients are people who do web things, but I'm not interested in selling services, for example, on how to optimize a database. Like, I think it's a really legit problem, but it's not one that I'm interested in. I'm interested more in problems of how do you connect things to make physical artifacts, to create interesting experiences, to make compelling visuals. Those are the kind of problems that I'm interested in. And that's where I kind of draw the limit between computational design as using techniques of software development, writing code, and technology in general, but for creative purposes, right? Not for perhaps engineering purposes. engineering being defined as very scientific and very rigorous problem solving, if you will. Here, the problems that I'm interested in solving, design problems, are more related to experiences, emotions, that kind of like more qualitative kind of output. That is where I set myself, or what I'm interested in. I'm come from architecture, which is a field where you typically design buildings to make people feel good. That's kind of a very, very superficial summary of what architecture is about, but it's kind of legit in a way as well, right? So if you want to become a good computational designer, well, this is a good place to start. Learning skills, so learning how to write software, it's also quite useful. I would suggest that you do a lot of projects, so either independently or for someone. I suggest that you, whatever you do, you enjoy it, because if you're working on things that you don't enjoy, it's kind of difficult to become better or to progress. So that would be my advice. Um, yeah, and those are my 2 or my 3 cents. Andres, maybe there's a way to keeping maximum logs. Yes, that should be something, but you're welcome to implement that as an input, maximum logs. You read the input and you just output the last few lines. That should be very easy to do. Okay. And with that, I think I'm gonna call it a day. I have a lot of work this afternoon to do. Do I have anything on my agenda? Oh boy, am I missing some appointment? Oh, I have an interview this afternoon, actually. Uh, all right. Okay, I think that's it. Thank you very much, everyone. Thank you very much, everyone. As usual, I enjoyed tremendously doing this in good company. Thank you for being here. I will edit the videos and post them sometime soon, hopefully next week. And in the meantime, I hope you have a wonderful weekend. If you're not freezing like we are in Boston right now. And I will see you hopefully next week and next Friday. All right. Bye bye, everyone. Thank you.